Hi, this is the video abstract for the paper Building Confidence in STEM Students Through Breaking Unseen Barriers for Geoscience Communication. A paper by Phil Heron and Jamie Williams, shown here. So this paper is predominantly about the outreach course, Think Like a Scientist, which is a 7-week course designed to teach students about science, but to build their confidence as well. So myself and Jamie run Think Like a Scientist. I'm a geoscientist at the University of Toronto. Jamie is a experienced specialist in higher education, working with adults with autism in higher education for over a decade and he's also got a kind of a psychology background as well. So we've put together Think Like a Scientist, and we thought we'd create a paper to kind of give our formal framework for how we try and build confidence in students. The work here has predominantly been done in prison, but we've been applying this method of teaching to different areas as well. In prison, prisons are meant to work by people coming into prison and then coming out with a reduced rate of reoffending. And one of the ways to do that is to get people prepared for employment, and that reduces the rate of reoffending. But to get people into employment, you have to basically get people into education while they're in prison. This has kind of been talked about by the Ministry of Justice. The main issue is, though, that people in prison often don't want to access education. The reason being due to multifaceted issues there, due to having low confidence in themselves, having low confidence in the system, having stereotypes, not wanting to go into education, a lot of different gender issues, racial issues. So we decided to build a course that kind of works from there. And one of the kind of key parts of the course is that actually, failing in education and failing in science is part of the process. So we teach the scientific method, which has failure built into it. So the scientific method we go over in the paper is, firstly, you ask a question, such as, why does the light not turn on in the room? Let's just say you walk into a room and the light's not working. We then construct a hypothesis. Okay, is the light bulb burnt out? We conduct experiments. We replace the light bulb as an example. We have kind of an understanding section where we wonder, has it fixed the problem? And then a kind of analysis. If it hasn't fixed the problem, then why hasn't it fixed the problem? And then we kind of have a reckoning where we go, does this answer our research question? Yes, we communicate that finding. But actually, more often than not, what we do doesn't answer the question, and we don't know, and actually that is failure. And we teach that in Think Like a Scientist, that actually failure is part of the process, and then we kind of start the steps again. And even if there's no right answer, we still have to communicate. Failure is part of the communication process as well. So share findings even if there's no answer. And that kind of starts the ball rolling in terms of trying to start to break down these barriers, that actually there's, failure is okay. I don't know about everyone else, but my 99% of my job as a scientist ends in failure. Nothing works ever. So building that as part of the process kind of sets the tone for the course. And these are kind of, light bulbs are kind of an easy, relatable thing to get into, but you can build this up to other examples such as fracking, etc. So the course is really basic in a lot of ways. It's just pen and paper and kind of a discussion around a whiteboard, and that allows a kind of a community feel as well to the class. There's no need to engage with any higher technology than what is basically around you. So this paper kind of bases its evaluation on some data that was collected in part of post-course evaluations and pre-course evaluations, as well as our experience in kind of discussing the work, going into prisons and talking to people. Very small cohort of people with this data, but we kind of want to make a more formal declaration at the moment before we go on to do more longitudinal studies. So basically what we found is how can we build student confidence in prison? And the first part is to make the content relatable. Especially in prison, students want to be able to have some relatability to the content, and that's kind of a bit of a challenge, but you can make it relatable. There's a really nice relationship between an astronaut and a person in prison. You know, they're away from their families a long time. They're kind of with the surrounding people in a closed space for a long time. You can make content relatable, and that allows students to kind of leap over one of the barriers. Accessible, making the course accessible, and that could be a number of different things, leading to having a classroom which is away from the traditional classroom settings, so that there's not that stigma with the traditional classroom setting. Also kind of plain speak language, you know, not trying to increase complexity early on. Inclusivity is also really really important. So breaking down that kind of grading system to allow people to want to enter. Also having questions and having discussions on scientific problems that have no consensus creates a kind of a community aspect, because you're allowing people to express themselves on problems that aren't currently solved and there's no consensus. And also encouragement by, if anyone hands in any work, you really kind of show appreciation for it and encourage work, because that also really allows progression. So it's kind of a simple method, the RAY method, which we outline in the paper, but it's not just in prison. And this can be in a number of different classroom environments. Doesn't have to be just prison. And also it could be for outreach programs. It could work in outreach programs that you're going to talk to students which have potential students which have low confidence. So the kind of impact is that from this kind of small cohort, you could see that the course was interesting, increased interest in science. People would take this course again, encourage students to think for themselves, building that confidence. A student, this is not mentioned in the paper, Dalton, he was released from prison after the course and wrote about it in a magazine, saying that he found his freedom studying science in prison. And what Dalton says about science is that science taught me to connect ideas, take notes, create plans, and to figure out routes. It showed me that scientists will take a chance. If it doesn't work, they'll find another way and another way, and that you can build ideas through other people's work and add on, develop teamwork, build on failure as an achievement, and above all, learn to keep going forward, which is kind of sums up the work here. So how do you break down unseen barriers? At the end of the paper, we give a little overview of some of the things you can do. Here are a few of them. Create a neutral classroom dynamic, have the class focus on dialogue, produce content that is relatable, ask questions with no scientific consensus to promote discussion, implement clean speak English, which we go into in the paper, and emphasize encouragement when marking work. That's our paper. We are available to discuss it and to consult on any work. We've been doing this a little while, and we enjoy talking to people about this sort of work, and we're learning as well. So get in touch if there's things that we can do in our course to help improve going forward. So thank you on behalf of myself and Jamie, and a big thanks to the European Geosciences Union and the European Union Horizons 2020, which helped fund this. And there's a whole host of people who helped as well. So thank you.